So I'm Randy Spicer. I graduated with a bachelor's from Virginia Tech in aerospace engineering in 2006, master's in aerospace engineering in 2007, and am currently a PhD student in space engineering at Virginia Tech. After leaving Blacksburg in 2007, I went to Dulles, Virginia to start my career at Orbital Sciences Corporation, and have been at the same campus for almost 14 years now, but worked at three different companies. So Orbital Sciences became Orbital ATK, which is now Northrop Grumman Space Systems. I started my career as a mechanical analyst, looking at stress and dynamic loads, finite element analysis, for making sure the spacecraft can survive launch. I did a lot of testing of full integrated spacecraft, actually putting the whole spacecraft on shaker tables and testing them to make sure that they can actually survive launch, making sure our models accurately represent the as tested conditions, and also acoustic testing, shock testing, and different dynamic testing. After that, I went into an engineering rotation where I first went to electrical engineering and kind of did something completely different. Had a lot of fun there. Built a spacecraft from electrical side, from basically the beginning of the build all the way up until launch. I got to travel to French Guiana and actually launched the spacecraft from there, and that was pretty exciting. Then I went into system engineering. I've had a couple different roles in system engineering, but right now my role is I do a lot of research and development of new systems. I work on a lot of small programs with small teams, but you get to do a lot of kind of cutting edge stuff, which is really interesting. Um, I wanted to be an aerospace engineer since I was pretty young kid. I was like in the fourth or fifth grade when I decided. My dad took me to the Air and Space Museum, and we saw this IMAX presentation on colonizing Mars, and that was years and years ago. And I just remember having my mind blown as a little kid and being like, that's what I want to do. And so I stuck with it all the way through college, and now I'm working in the space field and spend my days designing spacecraft and rockets. I think something definitely needs to be done. You know, what comes out, what policies come out, or what guidelines people start following. There's sort of some standards of deorbit within 25 years, but for some of these constellations of thousands of satellites, if it takes 25 years for all those thousands of satellites to deorbit, maybe that's not fast enough. So I definitely think it's something that people are looking at, need to look at more, and that there probably does need to be some policy. I think we're learning that some of these really big systems that we had before might not be the best way to do things, especially when you consider how hard it is to replenish those really big systems. So instead, if we have some smaller systems that might be not be quite as capable, but may be able to work in collaboration with a bunch of different satellites, now you have a system that can be as robust as those bigger systems. But easier to refresh, easier to launch, and a little bit more resilient, because if one part of the satellite fails, one small satellite fails, it might not be that big of a deal. Whereas if you have something go wrong on one of these really big satellites, you've lost your entire system. So I think that there's a lot of opportunity out there, a lot of different business cases that people are looking at, and I think that small satellites are here to stay. So I think Virginia Tech gave me a good head start getting into my engineering career. I know that when I started, I was working with a lot of really small people. A lot of them came from Virginia Tech, but we also had people from MIT and other high institutions as well. And I felt like Virginia Tech did prepare me well. I was able to get up to speed pretty quickly and collaborate with my peers, and was given a lot of responsibility early on. And so, having that background in engineering from a great institution like Virginia Tech was really helpful to start my career. And I've continued to try to learn through the years. I got a second master's degree in system engineering, and now I'm working on my PhD in space engineering from Virginia Tech. Capstone Design is really the culmination of your entire undergraduate career, where you're taking all of the different engineering skills you've learned and putting it together and actually applying it to an actual problem solving, working in a much bigger group than you're used to working with, and doing it for a prolonged period of time, where you're working with the same team for an entire semester. Um, so I think capstone design is really important. I remember when I did my capstone design project, I really felt, ownership of the project. We all were really engaged and really want to do a really good job of taking all of these engineering skills, propulsion, attitude control, orbit design, all of structures, all of it, and then putting it together and actually creating something, even if it was just on paper. It was really important and interesting and fun. And I think it was one of the highlights of my entire college career. I would say that process is very important, and I like to tell students now that my job, especially since I work with small teams and doing this research and development kind of small rapid projects, feels a lot like senior design every single day. I'm working with the same group of people. We're coming up with problems. We're doing hand calculations to solve things. I pull out my textbooks and refer to the equations in them, and we're just working together, and the pace isn't even really that far off. I mean, a lot of the stuff that we do only lasts a couple of years, so maybe a little bit longer than senior design, but not much different. And so I tell the students, this is what your engineering career could look like from now on. And so make the most of your senior design project. Do a good job, because this is what your job's going to be like when you get out into industry and or start designing your own satellites and systems. So I think it is really important. Northrop Grumman, I think, sees a lot of value in outreach to universities and collaboration with universities. We have a strong relationship with Virginia Tech, and we've collaborated through senior design. We've collaborated through just outreach in general. We've collaborated with recruiting, and we've collaborated with getting uh, Northrop Grumman employees degrees through Virginia Tech. We're collaborating now with seeing what we can do with the Innovation Campus. So I think we see a lot of value in the outreach. So Northrop Grumman has supported me with engaging with senior design now for, I think, 5 years, and continues to do it because they see value. They see value in reaching out to the students and showing them this is what an industry engineer thinks of your project, and this is how you can make it better. And we also see value in looking at the students and seeing, hey, these are great students. Can we bring them to Northrop and have them do great work here as well? So there's definitely a mutual benefit. I think there's a lot going on in space right now. Everything from returning to the moon to trying to reach out to Mars, the Earth science that we're doing, and the new shift right now where people are thinking about, well, what if something's too big to build on the ground and fly to space? Why don't we try building things in space? I think all of these things are really exciting. As I mentioned before, the increased access to space. It's easier to get to space now than it's ever been before, and so more people and more institutions and universities and even high schools now are building satellites to fly to space. And so I think it's going to be exciting because the more often we get to space, the easier it's going to be, and the more we can do once we get there. I think obviously, returning to the moon and returning to Mars, I think, or journeying to Mars for the first time, I think will be something that I'd really like to see in my lifetime. But I'd also like to see us build stuff in space, build something really big and amazing in low Earth orbit or cislunar space or wherever, and start taking some of these concepts that have been working on, and taking these concepts that NASA's been developing, the Space Force developing, everything, and try to see what we can really really do. So for Virginia Tech students, I would say make the most of your college career. Any students who have been at school for the past couple of years have had some extra challenges, which we're hopefully getting past soon here. But I think you guys have done a good job of making the most of your college career. I've worked with some students who were seniors this year, and it definitely seemed like things were harder for them. But I also saw students making the most out of bad situations, doing the right thing, and looking out for their friends and everything. So I think keep doing what you're doing, and uh, you guys will do good work when you get to industry. For alumni, reach out to students and engage with them. It's a very uh, rewarding experience. The students get something out of it. Us in industry get something out of it, and yeah, go Hokies.